Now, continuation, here already explained last class distance and displacement. Now, distance is scalar, velocity displacement is vector. Next we have speed. Speed means what? Speed, distance by, speed is equal to what? Distance by time, distance by time. Speed is equal to distance by time. Now, distance travelled by a body in unit time, distance travelled by a body in unit time is equal to what? Speed. Again we have velocity, velocity V bar is equal to what we write? S bar by T. Displacement by time, displacement of a body in unit time, that is velocity. Otherwise, speed of a body in particular direction. Suppose if the body moves from A to B, if the body moves from A to B, distance how much? AB, displacement how much? AB only. So, what we say displacement? Distance travelled by a body in particular direction. If a body moves from A to B, so distance and displacements are equal, distance and displacements are equal. So, like that speed, distance, displacements are equal, speed and velocity also equal. Now, speed of a body in particular direction. Here if a particle or body moves along one direction, distance and displacements are equal. AB is distance and AB also displacement. So, that is why speed and velocity, velocity what is that? Displacement of a body in unit time, displacement of a body in unit time is called velocity. Otherwise, speed of a body in particular direction, speed of a body in particular direction is called what? Velocity. Now, here displacement is equal to what we write? Velocity into time, displacement is equal to velocity into time. And also next we have average velocity, next we have average velocity. What is average velocity? V average is equal to total displacement by total time, total displacement by total time, S by T, S bar by T. Ratio of total distance by total displacement by total time is called what? Average velocity. And also we have, so average velocity how much? Ratio of total displacement to the total time taken, that is average velocity. And also we have average speed, average speed means total distance by total time. And also we have instantaneous speed, instantaneous speed means what? A speed of a body at a particular instant of time, speed of a body at a particular instant of time is called what? Instantaneous speed. Now, in a car, speedometer of a vehicle, speedometer of a vehicle gives what? Instantaneous speed. Its value is different at different instants. We are going fast, immediately it shows 60, 80 like that. If I apply brakes, immediately comes to 0 like that, 30, 40. Speed of a body at a particular instant, speed of a body at a particular instant is called what? Instantaneous speed. And also velocity of a body at a particular instant is called what? Instantaneous velocity. So, mathematically what we write? Here instantaneous velocity ds by dt, ds is the small displacement in time dt. Now, velocity is what we write? Ds by dt, ds bar by dt bar, ds bar by dt bar like that. And also we have here uniform speed or velocity, uniform speed. Uniform speed means what? Body covers equal distances in equal intervals of time, body covers equal distances in equal intervals of time. First hour it travels 20 kilometers, next hour also it travels 20. Here if a body covers equal distances in equal intervals of time, body covers equal distances in equal intervals of time, body is said to be moving with what? Uniform speed. In the same way, suppose if a body covers equal displacements in equal intervals of time, body covers equal displacements in equal intervals of time, body is said to be moving with what? Average velocity, average velocity. What is that? Uniform velocity, uniform speed and uniform velocity. Uniform velocity means what? Body covers equal displacements in equal intervals of time. So, and also in each hour it travels 20 kilometers, and in each minute how much it travels? 1 by 20 kilometers. Here in each hour it travels 20 kilometers, in each minute how much it travels? 1 by here in 60 minutes how much distance travels? 60 minutes 20 kilometers. 1 minute how much distance travels? 20 by 60 kilometers like this. In each hour it travels 60, each minute how much it travels? 20 by 60 kilometers. On that time body is said to be with what? Uniform speed. Body covers equal distances in equal intervals of time, however small these time intervals may be. However small these time intervals may be means what? In each minute it travels equal distance, in each second also it travels equal distance. that is called what? Uniform speed. Uniform speed, otherwise uniform velocity. What is uniform velocity? If a body covers equal displacements in equal intervals of time, equal displacements in equal intervals of time, body is said to move with uniform velocity. And non-uniform velocity means what? Body covers unequal displacements in equal intervals of time. Body covers unequal displacements in equal intervals of time. First hour it travels 30, second hour it travels 60, the next hour it travels 20, like that. Body covers unequal displacements in equal intervals of time or equal displacements in unequal intervals of time. Time is same, but displacements are different. So anyhow, body covers unequal displacements in equal intervals of time or equal displacements in unequal intervals of time. Body is said to be moving with what? Non-uniform velocity or variable velocity. Non-uniform velocity or variable velocity. And next we have acceleration. Acceleration. What is acceleration? Rate of change of velocity, v bar minus u bar by t. Here, what is v bar minus u bar? Change in velocity. What is t? Time. V bar minus u bar, what is that? Change in velocity. T, time. Change in velocity by time. That is called what? Acceleration. Now, rate of change of velocity is called what? Acceleration. Now, equal changes. Next we have uniform acceleration. What is uniform acceleration? Equal changes in velocity. Change in velocity is phi. Next second also change in velocity is phi. Equal changes in velocity. Equal changes in velocity in equal intervals of time. Change in velocity is same. Here in first second it travels phi. The change in velocity is phi. Next second also change in velocity how much? Phi. If a body possesses equal changes in velocity in equal intervals of time, body possesses what? Equal changes in velocity in equal intervals of time, body is said to be with uniform acceleration. Uniform acceleration. Otherwise, unequal changes in velocity takes place in equal intervals of time or equal changes in velocity in unequal intervals of time. So, on that time body is said to be with what? Non-uniform acceleration. Non-uniform acceleration. And also this acceleration is of two types: positive acceleration, negative acceleration. Positive acceleration or negative acceleration. Positive acceleration, velocity of a body increases. Train leaves the platform. Train leaves the platform, velocity of a train increases. It moves with positive acceleration. Freely falling body. Freely falling body, what happened? A freely falling body, velocity increases. For freely falling body, velocity increases, it moves with positive acceleration. For vertically projected body, goes on, velocity decreases, it moves with what? Negative acceleration. Train approaches the platform. Train approaches the platform, driver applies brakes. On that time, it moves with the decreasing velocity, negative acceleration or retardation. Positive acceleration, next one, what is that? Negative acceleration or retardation or de-acceleration. Negative acceleration or retardation or de-acceleration, whatever may be the acceleration. What is unit? What change in velocity is nothing but velocity. So, meter per second per second. So, meter per second square. Meter per second square is the unit of acceleration. Now, we have question like this, simple thing. A particle moves 5 meters, question like this. A particle moves 5 meter per second. A particle moves with a velocity 5 meter per second along east direction. Along east direction, in 10 seconds, its velocity, its direction changes. Again, it moves with the same velocity. Here, a particle moves with 5 meter per second along east direction. In 10 seconds, its velocity, it moves, continues to move with the same velocity, but in north direction. What we take now? 5j cap. Understand question? A particle moves with a velocity 5 meter per second along east direction. In 10 seconds, it changes its direction. It continues to move with the same velocity. So, same magnitude of velocity. How we take directions on the paper? North to south, north to south, east to west, east to west, like this. Now, 5 meters east direction is taken as x-axis, north direction is taken as y-axis. A particle moves 5 meters, a particle moves with a velocity 5 meter per second along east direction. East direction is taken as x-axis. That is why what we write? 5y cap. And in 10 seconds, it moves with the same velocity, but direction changes, north direction. North direction is perpendicular to east direction. So, velocity v bar how much? 5j cap. Find the acceleration. Find the acceleration. What is formula? Acceleration is equal to how much? V bar minus u bar by t. V bar how much? 5j cap minus 5 I cap by t how much? 10. How much now? 5 by 10 j cap minus 5 I cap by 10. 5 1s, 5 2s, 5 1, 5 2s. How much acceleration vector? 1 by 2 j cap minus 1 by 2 I cap. What is the acceleration vector here? 1 by 2 j cap minus 1 by 2 I cap. Now, what is the magnitude of acceleration? Magnitude of acceleration is under root of 1 by 2 whole square plus minus 1 by 2 whole square. How much? What we are getting? 2 into 1 by 2 whole square, 1 by 2 into root 2. So, we are getting 1 by root 2, 1 by root 2 meter per second square. Is it clear? What is acceleration now? 1 by root 2 meter per second square. Direction, here x coordinate, I cap coefficient, y cap coefficient, I cap coefficient and j cap coefficients are equal. Tan 45, tan theta how much? Tan theta is equal to ay by ax, ay by ax. Tan theta is equal to ay by ax. Ay how much? 1 by 2. Ax also 1 by 2. We take magnitudes only. How much? 1. So, tan theta is equal to 1. So, for which angle tan value 1? 45 degrees. Theta is 45 degrees. Now, here positive x axis or negative x axis, j cap is positive, I cap is negative. J cap is positive, I cap is negative means what? Which quadrant? Second quadrant. Here with the negative x axis 45 degrees. This is acceleration. So, what we say direction? 45 degrees clockwise or anti-clockwise? 45 degrees clockwise. 45 degrees clockwise. What we say simply direction? Northwest. Northwest. What they are giving options? 1 by root 2 meter per second square, northeast, northwest, 0, none of these. Here velocity is same. 5 minus 5, if I not consider vector, suppose you are not taking vectors, 5 minus 5 how much? 0. First option 0 only. What is question? First you understand question. A particle moving with a velocity 5 meter per second along east direction, in 10 seconds it continues to move with the same velocity along north direction. Continue to move with the same velocity in north direction. So, initial velocity 5 I cap, final velocity how much? 5 j cap. So, find the acceleration. First option 0, 5 minus 5 0. So, but it is wrong option. What is correct option? 1 by root 2 meter per second square northwest. So, they are giving one more option, 1 by root 2 meter per second square northeast. Northeast one option, 1 by root 2 meter per second square northwest one option. Which is correct? 1 by root 2 meter per second square northwest. Why? Well, acceleration v bar minus u bar by t. So, what we are getting? 1 by 2 j cap minus 1 by 2 I cap. Which quadrant here? This is second quadrant. I cap is negative. So, what is direction? Northwest. Northwest. 1 by root 2 meter per second square northwest is the correct option. Is it clear? In this way we calculate acceleration like that. Next one. Now we discuss equations of motion. Here already explained speed, velocity, average displacement, and also we have equations of motion. Now what are equations of motion? Equations of motion. Here if a body moves with uniform acceleration, consider a body moving with uniform acceleration. What are equations of motion? V bar is equal to what? U bar plus A bar into T. Second equation of motion, S bar is equal to what? Ut plus half AT square. Third equation of motion, what is that? V square minus U square is equal to 2AS. Fourth equation of motion, Snth is equal to what we write? U plus A by 2 into 2n minus 1. Here like this. What is first equation of motion? It gives the relationship between initial velocity, acceleration, final velocity and time. Here second equation of motion. Here first equation of motion when we are using, what is this? It gives the relation between what? Initial velocity. What is U bar? Initial velocity. What is A bar? Uniform acceleration. Now all these equations of motion holds good when a body moving with uniform acceleration. That question also there. Equations of motion holds good When a body moves with non-uniform acceleration, variable acceleration, both none of these. What is that? Here equations of motion holds good when a body moves with what? Uniform acceleration. You know that uniform acceleration, what is that? Body possesses equal changes in velocity takes place in equal intervals of time, like that. On that time what we say? Body is said to be moving with uniform acceleration. Now, so V bar is equal to what? U bar plus A bar T. So, first equation of motion gives relation between what? Initial velocity, acceleration, time and final velocity. What is S bar? S bar be the displacement of a body in time t seconds. Total time, S bar be the total displacement in time t seconds, and third equation of motion. What is that? V square minus U square is equal to 2AS. So, in the absence of time, if you know initial velocity, final velocity, we calculate displacement and also acceleration. If you know initial velocity, final velocity, acceleration, we calculate displacement. Displacement is equal to what? V square minus U square by 2A. How we calculate acceleration? V square minus U square by 2S. In the absence of time, we are using third equation of motion. What is third equation of motion? V square minus U square is equal to what? 2AS. What is fourth equation of motion? Sn is equal to what? U plus A by 2 into 2n minus 1. What is Sn? Displacement of a body in particular nth second. Displacement of a body in particular nth second. Okay. These are equations of motion. Now, so depends on this, we have so many problems. Is it clear? What is S bar? S bar be the displacement of a body in time t seconds. What is Snth bar? Snth bar is the displacement of a body in particular nth second. Particular nth second, like that. And also we have equations of motion in the case of freely falling body and vertically projected body. Equations of motion in the case of freely falling body and vertically projected body. First of all, we discuss acceleration due to gravity. What is acceleration due to gravity? Acceleration due to gravity is represented by G bar. Here acceleration due to gravity is nothing but what? Acceleration of a freely falling body. Acceleration of a freely falling body due to gravitational force of attraction. What is the gravitational force? Suppose m be the mass of a body. What is the gravitational force? mg. Now, here, so resultant force ma is equal to what? fg. Acceleration acquired by the body due to gravitational force of attraction, mg by m. So, A is equal to what? G. So, acceleration of a freely falling body, acceleration of a freely falling body due to gravitational force of attraction is equal to what? Acceleration due to gravity. A is equal to how much? G. Now, so G is nothing but what? Acceleration only, acceleration to gravity. So, acceleration and acceleration to gravity both are same, both are having same units. Now, acceleration to gravity also vector. What is the direction of acceleration to gravity? It always acting direct, it is always directed downwards towards the center of the earth. It is always directed downwards towards the center of the earth when a body projected upwards or downwards. Why? Gravitation force always acting downwards. So, that is why acceleration to gravity always directed downwards towards the center of the earth when a body projected upwards or downwards. For freely falling body, A is equal to how much? Plus G. For vertically projected body, how much? Minus G. Now, this G value is different at different places. On the surface of the earth, what we take now? G is equal to 9.8 or 10 meter per second square. Meter per second square. In CGS system, what we take? 980 or 1000 centimeter per second square. 980 or 1000 centimeter per second square. So, its value changes from place to place. So, where we discuss in variation of G in due to latitude, altitude, depth, in gravitation chapter we will discuss. Okay. Now, what is this? Now, its value is constant on the surface of the earth. On the surface of the earth, what we take? 9.8 or 10. In SI system, CGS system, how much? 980 or 1000 centimeter per second square, like that. Now, so for freely falling body, how much we are taking? Plus G. For vertically projected body, minus G. But vectorially what we write? G into minus J cap. G into what? Minus J cap. It always directed downwards towards the center of the earth. So, along negative axis, what we take? Minus J cap, like that. Now, so for vertically projected body, what happened? It moves against the gravitation force of attraction. So, what we take? Minus G. For freely falling body, A is equal to plus G. But vectorially, how we represent? g into minus j cap. Minus j cap indicates what? Downwards. Now, I have discussed equations of motion in the case of freely falling body. Now, let a body is allowed to fall. Let a body is allowed to fall freely from a height h. On that time, acceleration how much? A is equal to how much? Plus g. Displacement how much? h. Now, suppose when a body strikes the ground with velocity v in time t seconds, time is t seconds, velocity is v, final velocity is v. Now, what is first equation of motion? Now, substituting these values in equations of motion. What is first equation of motion? V is equal to u plus at. Now, u is 0, a how much g, v is equal to how much gt, v is equal to gt. So, for freely falling body, t increases, velocity increases, g is constant. As time increases, if a time taken by a body to reach the ground increases, velocity increases. Next, second equation of motion. What is second equation of motion? S is equal to ut plus half at square, ut plus half at square. S how much here? H, u 0, 0 into t 0, half gt square. H is equal to how much? Half gt square. What is h here? Height. So, from this t is equal to how much? Root of 2h by g. What is this? T, time taken by a body in reaching the ground. Time taken by a body in reaching the ground. What is formula? Under root of 2h by g. So, t proportional to root h as height of a body increases, height reached by the body, what is h here? Dropping height. If a body falls from a height h, so time is directly proportional to what? Root h. H increases, time increases. What is second equation of motion? Freely falling body, h is equal to what? Half gt square. So, t is equal to what? Under root of 2h by g. What is t? Time taken by a body in reaching the ground. If a body falls from a height h, time taken by a body in reaching the ground, what is formula? T is equal to under root of 2h by g. T is equal to under root of 2h by g. Third equation of motion. What is that? V square minus u square is equal to 2as u 0. So, v square minus 0 is equal to 2gh. So, v square is equal to what? 2gh. V square is equal to 2gh. Next one, we have fourth equation of motion. What is fourth equation of motion? S nth is equal to how much? U plus a by 2 into 2n minus 1. S nth is equal to what we have? Fourth equation of motion, u plus a by 2 into 2n minus 1. So, S nth u 0, a by 2 into a how much here? G. So, g by 2 into 2n minus 1. From this, S nth is equal to g by 2 into 2n minus 1, like this. This is the fourth equation of motion. S nth proportional to what we write? 2n minus 1. Here h proportional to what we write? T square. H proportional to t square. Here S nth. S nth what we take now? H nth. H nth proportional to 2n minus 1. H nth proportional to what? 2n minus 1. So, how they are asking question? A body falls from a freely falling body. In case of what is the ratio of freely falling body? Here h nth proportional to what? 2n minus 1. So, in case of freely falling body, displacement in particular nth second proportional to what is that? Proportional to 2n minus 1. Total displacement proportional to what? T square. What is t here? Total time. H proportional to t square, S nth proportional to what? 2n minus 1. What is the ratio of distances travelled by the body? What is the ratio of distances travelled by a freely falling body in first second, second, third second? First second how much? 2 into 1 minus 1, 1. Second 2, n is 2, 4 minus 1, 3. Third second, 2, 3, 6, 6 minus 1, 5. Fourth second, 4, 2, 8, 8 minus 1, 7. Ratio of distances travelled by a freely falling body in first second, second, third second, fourth second. How much? 1:3:5:7:9 and so on. What is the ratio of displacement of a body in first second, 2 seconds, 3 seconds, 4 seconds? How much? H proportional to t square, 1:4:9. Ratio of displacements of a body in 1 second, 2 seconds, 3 seconds, 4 seconds, how much? 1:4:9:16. Here, ratio of displacements of a body in first second, second, third second, fourth second, how much? 1:3:5:7. Like that type of questions also there. Now, is it clear? Next, we have equations of motion in the case of vertically projected body. Equations of motion in the case of vertically projected body. equations of motion in the case of vertically projected body. Suppose let a body is projected vertically upwards, let a body is projected vertically upwards with initial velocity u from the ground. Now, let v be the velocity, let v be the velocity of a body at a height h from the ground. Now, this h is not equal to maximum height. What is maximum height? Here maximum vertical displacement of a body. What is the highest point here? Highest point is this. Suppose now P be the highest point. What is the highest point? The point at which final velocity is 0. The point at which final velocity is 0 is called what? Highest point. So, maximum vertical displacement of a particle from the ground. So, maximum vertical displacement how much is only capital H, let it be capital H. Now, so highest point when a body projected upwards, highest point reached by the body is called what? Maximum height. So, what is that? It is nothing but maximum vertical displacement of a particle, maximum vertical displacement of a particle from the ground is called what? Maximum height. So, here v be the velocity, v be the velocity at a height small h from the ground. So, this h is not equal to capital H, h is not equal to capital H. Now, here initial velocity is u, final velocity how much? V. Initial velocity is u, final velocity is v. When a body reaches maximum height, final velocity how much? 0. Time how much here? Time is t. Now, displacement how much? Displacement s is equal to h. Now, substituting these values in equations of motion. First equation of motion, what is that? V is equal to u plus at. So, now it becomes what? V is equal to u minus gt. After 1 second, velocity how much? U minus g. After 2 seconds, u minus 2g. After 3 seconds, u minus 3g. Goes on. When a body projected vertically upwards, its velocity goes on, decreases. Second equation of motion. What is second equation of motion? S is equal to ut plus half at square. Ut plus half at square. S how much here? H. H is equal to ut minus half gt square. Ut minus half gt square. Third equation of motion. What is that? V square minus u square is equal to 2as. Now, v square u how much? V square minus u square is equal to minus 2gh. Fourth equation of motion. What is that? S nth is equal to how much? U plus a by 2 into 2n minus 1. How much here? We are getting h nth is equal to u minus g by 2 into 2n minus 1, like this. This is fourth equation of motion. Is it clear? Here what I am saying, when a body projected upwards, body not reaches maximum height. Here v be the velocity of a body, v be the velocity of a body at a height h from the ground in time t seconds. Now, equations of motion, what are that? V is equal to u minus gt, h is equal to ut minus half gt square, v square minus u square is equal to minus 2gh, and h nth is equal to what? U minus g by 2 into 2n minus 1. Okay? These are the equations of motion in case of vertically projected body. And now discuss some important parameters for a vertically projected body. Now, here we have maximum height, time of ascent, time of descent. Now, what is maximum height? Already explained. Maximum height means what? When a body projected vertically upwards, highest point reached by the body or maximum vertical displacement of a body, from the ground is called what? Maximum height, like this. If a body projected vertically upwards, so P be the highest point means what? Final velocity is 0. This h is called what? Maximum height. So, what is initial velocity here? Initial velocity is equal to u. Final velocity how much? Initial velocity is u, final velocity is v. Now, acceleration is minus g. Displacement how much? h. Now, we want to calculate maximum height. Substituting these values in third equation of motion. What is that? V square minus u square is equal to 2as. V how much? 0. U square. 2 a how much? Minus g. S how much? h. Now, minus u square is equal to minus 2gh. Now, what we are getting? H is equal to u square by 2g. H is equal to u square by 2g. So, for a given place g is constant, h proportional to u square. Initial velocity increases, maximum height reached by the body increases. So, they are giving question, what is that? A body projected with some velocity, maximum height reached by the body is 5 meters. If the velocity of a body is doubled, find the maximum height reached by the body. Here velocity is doubled, so u1 is equal to what? We take u, u2 becomes what? 2u. So, what we write now? h2 by h1, h2 by h1 is equal to u2 by u1, u2 square by u1 square, like that, h proportional to u square. For a given place g is constant, for a given place g is constant. What is h here? Maximum height reached by the body. Next we have time of ascent. What is time of ascent? Is it clear? What is formula for maximum height? U square by 2g. What is u? Initial velocity. G, acceleration due to gravity, like that. Next we have time of ascent. What is time of ascent? Time taken by a vertically projected body. Time taken by a vertically projected body to reach maximum height. That is called what? Time of ascent. Time of ascent. So, initial velocity is 0. Final velocity how much here? V is equal to 0. Here final velocity how much? V is equal to 0. Now, acceleration is minus g. Displacement how much? H. So, h is equal to how much we got? U square by 2g. Now, here we calculate expression for time of ascent. What is time of ascent? Time taken by a vertically projected body. Time taken by a vertically projected body to reach maximum height. Initial velocity is u, final velocity is 0. Displacement h, acceleration how much? Minus g. Substituting these values in first equation of motion. What is that? V is equal to 0. U, a how much? Minus g. T is equal to what? Time of ascent. Time of ascent. From this, g T a is equal to what? U. Now, T a is equal to how much? U by g. Now, T a proportional to how much? U. T a proportional to U, like that. Time of ascent proportional to initial velocity. Here initial velocity increases, time of ascent increases. Initial velocity increases, time of ascent increases. What is time of ascent? Time taken by a vertically projected body to reach maximum height. Next we have time of descent. What is time of descent? Time taken by a freely falling body to reach the ground from maximum height. Time taken by, time of ascent means what? Time taken to go from what? Ground to the maximum height. Time of descent, time taken by a body to reach the ground from maximum height. Maximum height. So, that is time of descent. So, time of descent also how much? Time of descent also equal to u by g. Time of ascent is u by g, time of descent also u by g. So, for a vertically projected body, time of ascent is equal to time of descent, how much? U by g. Next we have time of flight. What is time of flight? Total time of travel. Total time of travel. T is equal to what? Sum of time of ascent plus time of descent. Now, how much? Time of flight is equal to 2u by g. Here initial velocity increases, time of flight increases. Okay. Sometimes in questions they are giving time of flight. What is initial velocity? Gt by 2. Time of flight, we know time of flight. So, initial velocity how much? Gt by 2, like that. Now, anyhow sum of time of ascent and time of descent is called what? Time of flight or time of travel. Total time of travel. Total time of travel. What is that? Total time spent in air. So, what is time, sum of time of ascent and time of descent? Total time taken by a body to go from point of projection to maximum height and come back to the point of projection. So, anyhow it is nothing but total time spent in air. Total time spent in air is called what? Time of flight, like that. Next one. Here we have one question. A body projected vertically upwards with 100 meter per second. Find the displacement of a body in the last second of upward motion. What is question now? A body projected vertically upwards with velocity 100 meter per second. A body projected vertically upwards with velocity how much? 100 meter per second. Find the displacement of a body in the last second. Find the displacement of a body in the last second. How we calculate now? Like this. Find the displacement of a body in the last second of upward motion. Suppose this is the last second, body projected like this, last second of upward motion, last second of upward motion. Suppose 100 meter per second, time of ascent how much? Time of ascent how much? U by g, 100 by 10, how much? 10 seconds. So, what is last second? 10th second. Now, we want to calculate displacement of a body in 10th second. How we calculate now? here body projected vertically upwards, body projected vertically upwards. Now, displacement of a body in the last second of upward motion, last second of upward motion. How we calculate? Here last second of upward motion is nothing but what? Here displacement of a body in last second of upward motion is equal to displacement of a freely falling body in the displacement of a body in the last second of upward motion is nothing but what? Displacement of a freely falling body in the first second of downward motion, first second of downward motion. In downward motion, initial velocity how much? 0, a how much? Plus g. Now, S1 how much? S is equal to fourth equation of motion, Sn is equal to how much? U plus a by 2 into 2n minus 1. So, S1 is equal to how much? 0 plus g by 2 into 2n minus 1. S1 how much? 2 into 1. How much we are getting now? G by 2 into 2 minus 1. How much? G by 2 into 2. 2 minus 1? 1. So, G by 2. How much? 4.9 or 5. So, displacement of a here how much we are getting? 4.9. It is independent of initial velocity of projection. A body projected with velocity 100 meter per second, whatever it may be, displacement of a vertically projected body in the last second, displacement of a vertically projected body in the last second of upward motion is nothing but displacement of a freely falling body in the first second of downward motion. That is why how much here? 4.9 meters. It is independent of initial velocity of projection. Body projected with whatever may be the velocity. Here how much we are getting? 4.9 meter per second. Is it clear? So, what we understand? It is independent of initial velocity of projection. It may be 100, 200, 500, 510, whatever it may be. Displacement of a body in the last second of upward motion is equal to how much? 4.9 meters. 4.9 meters, like that. And also next we have here we have so many problems on average velocity and average speed. How? Here particle covers half of the displacement, a particle covers half of the displacement with a velocity v1 and remaining half of the displacement with velocity v2. Find average velocity. A particle covers half of the displacement with velocity v1, remaining half of the displacement with velocity v2. Find average velocity. V average, like this. How we calculate now? Average velocity. Average velocity is equal to what? Total displacement by total time. Suppose your displacement is same, velocities are different, so times also different. How much here? S by time how much? T1 plus T2. S by T1 how much? Time is equal to what by formula? Velocity is equal to displacement by time, time is equal to what? Displacement by velocity. Displacement how much here? S by 2 by V1 plus S by 2 by V2. How much now? What we are getting? V average is equal to total displacement by total time how much here? What we take in denominator? We take S by 2 common. What we are getting now? 1 by V1 plus 1 by V2, like this. SS gets cancelled. Now, what we are getting? 2 V1 V2 by V1 plus V2, like this. If a particle covers half of the displacement with the velocity v1 and remaining half of the displacement with the velocity v2, average velocity how much? 2 v1 v2 by v1 plus v2, 2 v1 v2 by v1 plus v2, like that. And also instead of this, if a particle covers 1/3 of the displacement with a velocity v1, remaining 1/3 of the displacement with a velocity v2, find average velocity. Same thing, 1/3 of the displacement how much with a velocity v1, second 1/3 velocity how much? v1 or v1 bar, v2 bar, v3 bar. Same thing, what we are getting on the time? S by 3 by v1, S by 3 by v2, S by 3 by v3, like that. On the time we are getting here 3 S1, S2, S3 by same formula we are using, S by 3 we take common. So, on that time we are getting here total displacement how much? S S by 3, what we are getting? 1 by V1 plus 1 by V2 plus 1 by V3. So, from this, what we are getting now? 3 V1 V2 V3 by how much? V2 V3 plus V1 V3 plus V1 V2, like this. This is the total displacement. Here, if a body covers 1/3 of the displacement with velocity V1, second 1/3 with the velocity V2, remaining 1/3 V3, average velocity how much? 3 V1 V2 V3 by 3 V1 bar V2 bar V3 bar by V2 V3 plus V1 V3 plus V1 V2, like that. So, they are giving values. Remember these formulas. Suppose a particle covers half of the displacement with velocity 20, remaining half with 30. How much? 2 into 20 into 30 by 20 plus 30, like that. Otherwise, here a particle travels half of the time with a velocity V1, remaining half of the time with velocity V2. Find average velocity. A particle covers half of the time with a velocity V1, half of the time a particle travels half of the time with a velocity V1 and remaining half of the time with a velocity V2. Find average velocity. How we calculate now? The average velocity is equal to total displacement by total time. Total time how much here? T only. Now, displacement how much here? Time is same, but velocity is different. So, S1 S2. So, S1 plus S2. Total time how much? T. T. Time is displacement is equal to velocity into time. So, V1 into T by 2 plus V2 into T by 2 by T. How much now? We take T by 2 common. What we are getting? V1 plus V2 by T. Now, T gets cancelled. What we are getting? V1 plus V2 by 2. What is the difference here? What I explained last case? A particle covers half of the displacement with velocity V1 and remaining half of the displacement with velocity V. How much we got on that time? 2 V1 V2 by V1 plus V2. But here, what is that? Half of the time with a velocity V1. A particle covers particle moves half of the time with a velocity V1 and remaining half of the time with a velocity V2. So, average velocity how much? V1 plus V2 by 2, V1 plus V2 by 2, like that. And also next we have vertical projection of a body from the top of a tower. Next we have vertical projection of a body from the top of a tower. Now, we derive expression for height of a tower. Here, like this. Suppose what we have? Vertical projection of a body from the top of a tower. For this, we consider a tower. We consider a tower AB of height h. Now, let a body is projected vertically upwards with initial velocity u from the top of a tower. So, on the time it reaches a height x above the tower and returns to the ground. It returns to the ground in time t seconds, like this. Initial velocity how much here? U. Acceleration how much? Minus g. Time taken by a body to reach the ground how much? T. Displacement how much here? AB of height how much? H. Displacement how much here? Minus h. Is it clear? Now, what is this? Vertical projection of a body from the top of a tower. Vertical projection of a body from the top of a tower. So, for this what we are consider? We consider tower AB of height h. Let a body is projected vertically upwards with initial velocity u. So, on the time it takes time, it reaches a height x above the tower and returns to the ground in time t seconds. Now, substituting these values in second equation of motion. What is second equation of motion? S is equal to how much? Ut plus half at square. How much here? You already explained. S is how much? Minus h. Minus h is equal to ut minus half gt square. Ut minus half gt square. H is equal to how much? Half gt square minus ut. Half gt square minus ut. What is h? Height of a tower. What is t? Time taken by a body in reaching the ground. It is the quadratic equation in t. What we write now? Half gt square minus ut. Half gt square minus ut minus h is equal to 0. So, it is quadratic equation in t. We calculate time t. Okay. So, depends on this also we have problems. Is it clear? What is h here? Height of a tower. Height of a tower. Height of a tower how much? Half gt square minus ut. What is u? Initial velocity. What is t? Time taken by a body in reaching the ground. Time taken by a body in reaching the ground, like that. Okay. So, sometimes directly they are asking find the time taken by a body in reaching the ground. How? It is quadratic equation in T, quadratic equation in T. So, now it is compared with what? AT square plus BT plus C. A value how much of G, B how much minus U, time how much T. So, again we are using minus B plus R minus, what is formula for B time? T is equal to how much? Minus B plus R minus B square minus 4AC by 2A. By using that formula, we calculate time taken by a body in reaching the ground, like that. Okay. And also here, so depends on anyhow depends on equations of motion, total kinematics depends on what? Equations of motion. We have equations of motion 4 only, but we have different types of problems. So, once you read total theory and you do problems. Okay. And also next we have, this is motion in a straight line. So, next we have in kinematics only we have motion in a plane. Motion in a straight line means what?